This is the second video for surface area and problem solving. For the second question, we are going to answer this question. How much paint would be needed to paint this prism if the bottom isn't painted? So again, we have a rectangular prism. This time we have 3 different measurements. 3 inches equals the length, 5 inches equals the width, and 8 inches equals the height. We should answer these 3 questions before we begin. How many faces are being painted? Since the bottom is not being painted, we are going to be painting 5 faces. Are any of the faces congruent? Yes. The front and back are congruent, as are the sides to one another and the top and bottom. And what shape are the faces? They are all rectangles. To begin, we'd start with our surface area formula, which equals 2LW plus 2LH plus 2WH. Since we're multiplying all of these sides by 2, that means we're accounting for 6 faces. In this example, we do not want to include the bottom. The bottom would be down here and would have side lengths of length times width. We're going to modify this equation and get rid of the 2LW. Instead, we are going to begin with surface area equals LW plus 2LH plus 2WH. When we substitute those numbers in, we will get 3 times 5 plus 2 times 3 times 8 plus 2 times 5 times 8. When simplified, 3 times 5 equals 15, plus 2 times 3 times 8, which equals 48, plus 2 times 5 times 8, which is 80, and our total would be 143 inches squared. Here's a question that I want you to try. This is a room that is having all 4 walls painted. We're trying to determine that surface area. Feel free to pause this video and try this on your own. On the next slide, I will have the answers for you. Okay, so with this, we know that there are 4 walls, so 4 faces are going to be painted. And they are all congruent, they're all the same. Each wall is 3.6 meters long by 2.4 meters wide. Since I know that's the dimension of all the 4 walls, I'm going to use this formula. Surface area equals 4 times the length times the width. When I substitute the values in and multiply them, my final answer will be 34.56 meters squared. The last question for this video is using a triangular prism. A roofer is shingling an entire roof in the shape of a triangular prism. What is the total surface area the roofer needs to shingle? If one package of shingles covers 50 square meters, how many packages need to be purchased? This is a 2-step question. So as like in the other video and in the other examples, we're going to figure out how many faces we need to cover. In this example, we are going to cover the 2 tops as well as the 2 triangles, so that will be 4 faces. The surface area of a triangular prism is calculated by using this formula. 2 times base times height divided by 2 plus rectangle 1 and rectangle 2 and rectangle 3. In this example, rectangle 3 would be the base. We're not going to shingle, so we'll ignore that part. To begin with the triangles, the base of the triangle is 8 and the height is 4. I'm going to substitute that in for the area of the triangles. For the first side, right over here, for the roof, the dimensions are 12 by 5. And since that's a rectangle, we'll multiply those two numbers together. And the opposite side is congruent. It is also 12 by 5. Okay, so to continue, inside the set of brackets, 8 times 4 is 32, divided by 2 is 16. 12 times 5 is 60. And again, 12 times 5 is 60. I'll continue to simplify. 2 times 16 is 32, plus 60, plus 60. And that will give me a total of 152 meters squared. That's the total surface area that will be shingled. Now the second step of this question is asking us to figure out how many packages to buy. So I'm going to start by taking the surface area, which is 152 square meters, and dividing it by the amount that one package covers, which is 50 meters squared. When I do the math, I'm going to get a decimal number. I'm going to get 3.04. And that tells me that I need 3.04 packages. In a real-life scenario, we couldn't buy 0.4 of a package, so we'd have to round up if we really wanted to cover this and have 4 full packages. There would be quite a lot left over, but at least we'd be able to cover the entire roof.